Hi, everyone. Thanks for coming to the SIG Apps talk. Today, we're going to talk about managing data at scale, best practices, and evolution of SIG Apps. So what is SIG Apps? We focus on application user experience, including the experience for app developers and app operators. We own the core Workloads API, including the deployment, StatefulSet, daemonset, job, and cron job. We also help developing the application level tools and standards on, for example, the tools like Helm and Compose that some of you may have heard is under SIG Apps. We also sponsor some working group like batch working group and serving working group. And this is the chairs of SIG Apps. I'm Janet.
My name is Maciej.
And then Ken Owens is not here, but maybe we'll see him in the future KubeCons. And this is our contact. We have bi-weekly meeting every Monday. And then we also have the Slack channel. And feel free to find us there. Now let's talk about a bunch of new features in this year. This is the max available for StatefulSet. This feature mainly focused on making the rollout faster so that we can improve the update speed and flexibility while still maintaining the controller availability. With that, I'm going to hand over to Maciej.
One tiny little comment. I would like to shout out to Hiba for this particular work because, as you probably noticed, a lot of the work that we do and the Kubernetes enhancements proposals, the CAP, the majority of them have 4-digit number. If you look carefully, this one is 3-digit one, which means it goes back way, way, way too much in the past. Like, if I remember correctly, somewhere around 2018. So if you do the math quickly, it's like 7 years in the works. We were really struggling to get people to help us with the work. There's only a handful of us who are working on the controllers, and yet at the same time, all of you and all of us rely on the core controllers. And so changing them is not that simple thing, and I'll be talking about because I have one specific use case, and I know that Philip is already looking at me because he knows what I'm going to be talking about. Janet covered the beta features that we promoted, literally this current release that is going to be out there early December or late November. I can't remember the exact date for 135 release. But we're very happy, and again, big shout out to Heba for her work and involvement in that particular one. But Janet also mentioned that a lot of the work that we are doing around the controllers is influenced by the working groups, primarily the batch working group, who are with us for a good 3 years by now. They are helping us to shape the job, specifically the batch workloads, primarily the job controller, to support various AI ML workloads. So this particular one, which is talking about backoff limits per index jobs for index jobs. If you remember, every single job has the ability to say, oh, I'm going to retry a particular work, and if I'm going to hit a specific number of issues with running the pods, I'm going to just decide that this is a failed job and I'm not going to try it anymore, and the entire job will be finished and marked as a failed one. But for index jobs, where each and every single index is doing certain part of the job, we didn't have the control because the backoff was always counted as a global thing throughout the entire job. And if you have an index job which spans, I don't know, thousands of pods, that not necessarily might be the case, and your desire to, I don't know, to have 10 pods failing because there you might know or you might have embedded in your logic that certain pods are okay to fail, or that you want to count the number of failures per pod, or specifically per index. So this particular feature introduces you that ability by adding information that, oh, I want to be able to specify this per index, and then we're counting the back off for every single index rather than globally across the entire job. That's where the spec back off limit per index field, which, as you probably assume, cannot be set with the other back off. Another one at the bottom, which is talking about job success completion policy. Something similar, again, coming from the batch working group. They basically wanted to be able to say, when can I mark a particular job, when it's ready, when it's not. Up to a certain point, we only had a notion of parallelism, which allows you to define how many jobs are executing, how many pods are executing a particular job in parallel. And there was the field completions, which was meant to say, oh, I want to reach this particular completions. But there are times when you want to complete ahead of time, or there are certain conditions how you want to decide them, that the job can reach the completion sooner than whatever is the end goal. And the job success completion policy allows you to have a little bit more control over the finishing, how the job ends. Another interesting work that came specifically from the queue project. Queue project is basically one of the mechanisms that allows queuing jobs and ensuring that your cluster, when you actually schedule the jobs, is ready to serve the entire job. Queue project is one of the sub-projects of the SIG Apps, primarily driven by the people from the batch working group again, because we're covering the batch. And so what they wanted to achieve is they wanted to be able to manage a job from within the queue. And the reason for that is, in a case where you have multiple clusters, you would like to have one cluster which serves as your hub and provides you an overview of what's going on with your job. So you can think of it like a master job where you are reflecting the status, and all the sub-jobs are then executed through multiple different clusters sometimes. Normally, if you create a job resource, the job controller, the built-in job controller, will kick in and will start acting on your job. In this particular case, it's totally reasonable for the job controller to kick in all the subclusters. But in the hub cluster, the only thing that you want to do is keep the job to be there as an information or as an aggregation source where you are summing all the information from the subclusters. So you don't want the controller to actually act on the job and create pods in your hub clusters. So for that point, the queue will actually kick in. It will say that they are in charge of this particular job, and they will summarize the information from all the subclusters, and you have a global view of what's going on in all the subclusters. So even though it was done primarily for queue, each and every single one of you can actually rely on this logic and introduce your own customization to the job controller, or eventually modify the logic that exists within the controller. Another interesting one was a pod replacement policy for jobs, like we were talking about. And again, the batch is taking the majority of our interest over the past couple of releases. Whenever a pod fails, there are options for how to replace the pod in a job. And not always you have the ability to do so. Let me give you an example. You are running 5,000, 10,000 pod job, and you only have a limited set of resources that you can do so. When any pod will fail, in normal cases, the job controller will immediately be figuring out that, oh, a pod failed, I have to replace it. if that happens 10, 20, or like bigger number, that can actually use more of the resources than you have available in your cluster or in your quota. So we've introduced a new field that allows you to control when you actually want to create the new pods, whether that's immediately after the pod is marked as a failed one, or whether you want to wait until the pod is fully terminated and releases all the resources from the cluster, and only then it will recreate the new pods. So that's where the pod replacement policy kicks in, and it helps you to achieve a little bit more stability for some of the job workloads. Okay, that's about it when it comes to batch workloads or stable features. Like I was saying, we have a lot of the work in progress for the next release and probably a couple more because there's a lot of topics that we are discussing, a lot of topics that are in progress. As you probably noticed, the work within our special interest group is going very slowly because since all of you already rely on those controllers, we need to be very careful. And the reason that I picked that particular image to depict this particular proposal is because that's what it roughly looks like. And I have a very good example from literally last week where we got a contributor who looked at the code and figured out, oh, you actually have those two methods, which are very identical. There's like tiny little difference in between the code in both of the methods. I looked at it and I thought through what could go wrong. They seem simple and safe to merge. And so I did, and that was a day prior to the code freeze. And long and behold, later that day, I'm hearing the entire queue is falling apart because about 80, 90% of jobs is failing one particular test. And I'm like, that can't be right. Is it possible that that one PR that I merged like 2 hours, 3 hours before is causing the issues? So I open a revert quickly before heading to bed. The next morning, I'm getting up, and I see that the PR merged, and the queue over the next 2 or 3 hours actually stabilized. So I have a big issue open describing all the changes and what happened, which test, where it failed, and I'll have to look carefully through that. That was actually in the deployment controller specifically. And the reason that I'm telling that is because this particular enhancement that Philip, who's sitting in the second row, is working and pushing hard. But the problem with that is, so the solution he's trying to achieve is something similar to what we were just discussing with regards to jobs. He wants to introduce a policy in a deployment that will allow you to tell, replace me the pods of my deployment immediately whenever they fail, or if you have a, I don't know, very restricted quota, or if you are working in a restricted environment and your deployment is pretty big, you want to wait until your pod finish and releases all the resources and only then gets replaced by a new one. So again, the goal is to save the resource usage and be more mindful of what you're using. The problem with that is that because the changes coming from that particular change are spanning the entire deployment and ReplicaSet controllers, both myself and Jordan were very careful because, like I said, a tiny little change in the deployment controller broke the entire thing. We're not even sure how much, if that change would land in a release, how many of your deployments it would actually break. Thankfully, we have very good and thorough testing. So we're talking with Philip about how we can ensure that the changes that he's proposing, which are very reasonable, how we can ensure that the changes are stable and well tested before we will be able to confidently say, yes, this is a good thing. The other interesting thing that is resolved as part of that thing is we are actually exposing the information of the terminating replicas in the status. And that's already landed, that was promoted to beta under a separate feature gate this past release, if I remember correctly. So you're going to see slowly popping up that field in your clusters as you are going to move to something newer. Another interesting topic that we started talking about recently again, but it was in the works for over a year or so, but we didn't get the necessary involvement for people to actually push this through, was basically what to do in case of a stuck deployment. As you probably, a quick show of hands, who run into this particular problem that you're rolling a new stateful set, and if one of the pods will fail, the entire rollout will be stuck. And the only reason to resolve it in a stateful set is that you have to manually go into your stateful set, either remove or fix manually the thing. I don't see any hands, but okay, there are a couple. So one of the main reasons behind the stateful sets was we wanted to ensure that the data is always secure, because stateful sets at the core were basically designed to ensure the data safetiness. But sadly, the downside is that if your stateful set gets stuck during the rollout, you have to manually intervene and fix the situation. So we're currently discussing whether we want to, or how we could improve users' life by exposing some knobs, allowing them to say, yes, I'm certain that you can roll or retry a particular pod. I'm fully aware that the data will be fine, because whatever you have with your data, you are able to handle that particular case. So we're discussing currently whether we want to introduce a new entirely strategy for stateful sets, which will be a recreate, which is some of you might be already familiar from deployment, because deployment either has a rolling strategy or a recreate, which basically means remove the entire thing and recreate from scratch. When we were initially writing stateful sets, we went just with the rolling upgrades, and that's the default and only policy currently available in a stateful set. In case of a recreate, we would basically removing the entire thing and recreating from scratch. So one option is either recreate or the ability to specify some kind of a progress deadline. Again, similar to what we have in a deployment, that after some time you can say, oh, you can consider that it failed and maybe try to roll back. So we are looking at the options. We will be having further discussions in the upcoming weeks, and we're hoping to push this through for 136. And this particular one is a new addition to the broad Kubernetes ecosystem. The gang scheduling is maybe not necessarily is a new topic. Some of you might have heard about Volcano and other solutions that provide gang scheduling. Gang scheduling at its core is basically the ability to say, this my application and all of their pods, whatever that will be, 5, 10, 1,000, they have to be scheduled at one. Currently, the scheduler works such that it will always go one pod at a time, and it will place them in your cluster. In a gang scheduling, you want to schedule all the pods in your gang in a single shot. So that's a thing that SIG scheduling is currently working, and as part of their work, they introduced something that is called a workload API, and the workload API is the description of your gang. And we will be working on the workload API over the next couple of releases, and we're trying to figure out how the workload description or the gang description will be fitting the workloads API. And by the workloads API, because that's where this is the complicated, I mean jobs, daemon sets, deployment, stateful set. I've already heard it's a little bit unfortunate because the Workloads API for SIG Apps is usually those controllers that I'm talking about. And the new resource is also called Workload API. So I've already heard people saying that the true workload controllers, that's deployment, StatefulSet, and the new Workload API, I know it'll be causing a lot of confusions, and we will be answering questions probably over the next 10, 20, 50 years about that. But yeah, if you are working in some of the AI, ML areas and you have some ideas how we could describe a group of pods within deployments, within jobs, because we know that the job will be the first one. And we've already had some preliminary discussion that, oh, I want to be able to point that this is the job and this is the workload. But the workload is already embedded deeply in a pod template. So we're talking back and forth because we are certain that we will have to change the notion of our controllers, but we just don't know how yet. So if you are working in that area, I'm pretty sure that we would like to hear from you about the future and what will come from that. Okay, I'll shut up and I'll pass Janet to cover the rest of the topics.
Yeah. One thing I want to add, which is not on the slide yet, is another work in progress is a PDB, the pod disruption support for the new workload API. That will depend on this work. So the gist of the work is that pod disruption budget is targeting each pod. But with the proposal, we are thinking about potentially the disruption should be considering the whole GAN instead of just a single replica. But that's still work in progress. So the next thing that I want to talk about is we make some changes to the official Kubernetes examples repository. That's also owned by SIG Apps. And we found that a lot of the examples are outdated or no longer works. Or not maintained, so we archive those. We also add a few up-to-date and AI examples there, and we're asking for more contributions there. If you are running AI on Kubernetes or you're running other types of applications on the examples repo, please feel free to give it a try or provide some more examples that can help others.
It's even totally fine because what we did, we basically archived, which means that there is _archive directory where we moved everything. If you notice that one of the examples old links are in the docs and you want to fix them, the fix is remove the link, not change the link to the _archived. Because the problem with everything under the archived is that it's either old or broken. But it's perfectly fine to get the examples from the archived and bring them back as long as they are fixed.
And this year in SIG Apps, we also have a new sub-project. We call it Agent Sandbox, which is also highlighted in the keynote yesterday. So the idea of Agent Sandbox is that we want to enable easy management of isolated stateful single workloads for use cases like AI agent runtimes. For example, for agent tool calls, you want it to be stateful. You only want a single replica. It's going to be, you need it to start up very fast, and you probably want to turn it down later after you're not using it. And you need more isolated container runtime like gvisor or Kata container. So this is focusing on that use cases. So this is still very early. We just started it this year, and feel free to scan the QR code and explore the repo. We also have a few examples for how we think that people can use this. But we are looking for more feedback and contributions for this sub-project. Now it's Q&A, and please scan the QR code if you need to contact us or have more information about SIG Apps.
Yeah, there's a mic in the middle if folks have any questions. I know we're close to lunch, so if you want to run to lunch, that's totally fine as well. We'll be hanging out in front of the stage for a couple more minutes. If people want to ask questions and are shy of mic, that's totally fine. We will be more than happy to answer all your questions or help you with any suggestions you might have. Thank you very much.
Thank you.